Hey guys, today we're going to work with section 2.1, patterns and inductive reasoning. Inductive reasoning is a type of reasoning that you get your conclusions based off of a pattern. So that's the key thing here, is that we're basing this off of a pattern. And so as an example, you see people walk into a building. Each person comes out with a small bag of food. So based off of that pattern, you conclude that there's a restaurant in this building. I like the example of when you go to the cafeteria that Monday they had pizza, Tuesday they had pizza, Wednesday they had pizza. So based off this pattern, you can probably guess that Thursday they have pizza. So let's make sure we can find some patterns. Now when we're looking at a numerical pattern and looking at a sequence, generally numbers are either added, subtracted, multiplied, or divided. So let's see if we can figure this one out. We're going from 3 to 9, 9 to 27, 27 to 81. Well, that's obviously not subtracting or dividing since we're getting bigger, and it's not adding. So let's check multiplication. So 3 times 3 is 9, times 3 is 27, times 3 is 81. So there's my pattern. So what I need to do to find my next terms is just keep multiplying by 3. 81 times 3 gives me 243. So that's my next term. And then 243 times 3 gives me 729. So those are my next two terms in my sequence. Now, sequences don't just have to be numbers, they can be pictures. So what's the next one in this sequence? So if you notice here, we have a circle with a triangle, a circle with a square, or any quadrilateral, a circle with a pentagon. So what do you think comes next? Yeah, you got it. A circle with a hexagon and a circle with a heptagon. Good job, you guys. What about this pattern? And see if we can figure out one here. Look at these circles, and what conjecture can you make about the number of regions that these 20 diameters form? So let's talk about this word here, conjecture. What a conjecture means is it's our guess. Based off of this pattern, let's guess. What do we think is going to happen? So if I have one diameter, how many spots do I have? Okay, well if I have one diameter, I end up with 2. If I have 2 diameters, I end up with 4 sections. If I have 3 diameters, I end up with 6 sections. So what's the pattern here? If I have 1 diameter, I end up with 2 sections. If I have 2 diameters, I end up with 4. If I have 3 diameters, I end up with 6. Yeah, we have to multiply by 2 each time. So if I have 20 diameters, I know I'm going to end up with 40 sections in my circle. Yeah, going back to a conjecture, like I said, it's our conclusion. It's our guess about what's going to happen based off of our pattern. So as you walk down the street, you see many people holding unopened umbrellas. You can make a conjecture that it might rain today. The forecast is calling for rain. What conjecture can you make about the sum of the first 30 even numbers? So again, we're going to look at a pattern here and see what we can figure out. So our first even number is 2. And 2 times 1 is 2. Our second even number is 2 plus 4, which gives us 6, which is the same thing as 2 times 3. Our third set of even numbers is 2 plus 4 plus 6, which is 12, which is 3 times 4. And our fourth set of even numbers is 2 plus 4 plus 6 plus 8, which gives us 20, which is 4 times 5. So is anybody seeing the pattern yet? So if I want to go through and find like my fifth one, it's going to be 5 times 6. If I want my sixth term, that's going to be 6 times 7. So my question is, what's my first 30? So that's going to have to be 29 times, that's going to have to be 30 times 31. So I need to know what is 30 times 31. So we have 31 times 30. So that's a 0 and a 3 and a 9. So my sum would be 930. Let's see if we can find a pattern from a graph. From data, sales of backpacks at a nationwide company decreased over a period of 6 consecutive months. What conjecture can you make about the number of backpacks the company will sell in May? So as you can see, these are decreasing over time. And looking at my data, I don't know what we're going to have in May. But if I draw in my line here, that's my line of best fit, which means this line here is going to be the one that it closely resembles my data. If I draw that in, I can see that in May there will be approximately 8,000 book bags sold based off of that pattern. A counterexample shows that a statement is false. So, such as an example is all apples are red. Well, a counterexample would be a Granny Smith apple. That one's green. So, that's telling me that what I said was false. So, sometimes we're going to be looking for things in math that are incorrect. So, let's see if we can come up with a counterexample here. If the name of a month starts with the letter J, it is a summer month. Well, think of all of your months that start with the letter J. So, we have January. We have June, and we have July. Which one is our counterexample? Which one says this statement is false? Yeah, January, not a summer month. Let's look at this other one. You can connect any 3 points to form a triangle. Well, yeah, I mean 3 points can make a triangle, right? If you've got them going, like point 1, point 2, point 3, but that's not always the case. Think about one of those good vocab words we learned last chapter. What about 3 collinear points? Yeah, that didn't make a triangle, that makes a line. Awesome. How about this one? When you multiply a number by 2, the product is greater than the original number. So let's break this down. Multiplication by 2. And product means our answer has to be greater. So let's look at some examples here. So our first example is let's multiply 2 by a positive number. So let's go with 3. 3 times 2 is 6, and our answer, 6, is greater than 3, so this supports our conjecture. This is not what we're looking for. Let's look at a negative number. Negative 4 times 2 equals negative 8, and negative 8 is not greater than negative 4, so any negative number would be a fantastic counterexample. Let's look at a fraction. How about 1/2 times 2? And that gives us 1, and well, 1 is greater than a half, so a fraction's not going to work. That's not going to be a good counterexample. And what about 0? 0 times 2 is, well, 0. And 0 is not greater than 0, so 0 would be another fantastic counterexample. So you could pick any negative number, or you could pick the number 0, and those would be counterexamples. And last one, what is a counterexample to the following conjecture? If a flower is red, then it's a rose. So, am I looking for a yellow rose? Is that what I'm looking for? No, I want another red flower that's not a rose. So maybe a lily or something like that that would be red. All right, you guys, have a good night.